In this regression video, we're going to talk about R-squared and standard error. There are complicated formulas for these ones, but we can really achieve all that very easily just using simple common sense and logic. So let's start with definitions. What exactly is R-squared? House prices depend on square feet, size, right? If a house is well priced in terms of square feet, would you buy it without even looking at it? Used car price depends on the miles driven. If the price is right for a used car in terms of number of miles driven, would you buy it without looking at it? The answer in both cases is no. Why not? Because square feet doesn't explain the full price of house. You have to worry about number of bedrooms, the lot size, the age of the house, the condition of the house. Similarly for cars, you need to worry about lots of other factors. So R squared comes in that context. So officially, this is what R squared is called coefficient of determination, and it gives the percentage of variance in the dependent variable, which is the price of the house, price of the car, and the independent variable, that's square feet or the number of miles driven. So for instance, for the house, R square is 0.83. That basically means that every square foot explains 83% of the price change of the house. The 17% is missing. That 17% belongs to other factors like number of bedrooms, the media rooms, the pool, the lot size, etc. If it's 0.74 for the car, which means the mileage explains about 74% the price variation in the car. 26% explained by other things, the car's condition, repair records, leather seats versus no leather seats, and so on and so forth. So that's what R square is. So let's start with our R square discussion. Then we'll also discuss standard error after that. There's a link available in the description that you can download it and then work with it. So what we have here is actual prices of the cars sold. This one is missing because I am not showing right now for a reason. So now we can do from Excel functions, intercept and slope, we can find the intercept and the slope. Slope is negative minus 0.191. That basically means that for each mile you drive, the price goes down by about 19 cents. So now we are interested in this car. Okay, it has 32,500 miles driven. What price should we expect for this car? What's our expected price? 16,085 for car number 13. Now the question is, why is this car selling for more than the average price of $14,670 some odd dollars? The reason being, you can explain that the car has only 32,500 miles, but the average car is 39,880 miles. So which basically means that this car has been driven less, so it should cost more. And understandable. So we predict the price of the car to be $16,085 when the average price is $14,670 some dollars. Now we look at the actual price of the car, and that happens to be $16,700. Now the question is, okay, yes, we agree that the car has fewer miles driven, so should cost more. $16,085 is fine, but how come it is even more, like $16,700? How come it is that much more? And only thing we can say is we do not know. Maybe the car is in a very good condition, maybe it's got some extra features, maybe got some two-tone paint or whatever. We do not know. That means we cannot explain that. We can only explain this price based on miles. We cannot explain this price because we do not know what it is. So what we have done is this. So here's the graph now. Average price is this one, 14,672. Average mile is 39,880 right there. And each dot is a car. So some cars are sold more than average price, some sold below average price. And you can see what you expect is that this is less than average miles, this is more than average miles. So less than average miles typically have more than average price. More than average miles will typically have less than average price. Of course, there are some exclusions too. This is lower but sold for lower price. This is more miles driven but sold for higher than average price. Now we focus on our card number 13 and card number 26. Card number 26 simply is average and average. That's equal and that's equal. So that's right in the right here dot. But card number 13 is right here. That's card number 13. And the price is sold at $16,700. And how far it is from the average price? $2,028. So basically, the average price of the cars is $14,672. It sold for $16,700. $2,028 more than the average price. And the predicted price was $16,085 that we got here. So once again, average price of the cars is $14,672. Our card number 13 sells for $16,700, when it should be sold at $16,085 according to our model. Okay? So now we could explain this much variation in the car price from our model. We could explain $1,413 there. This one we could explain. Why? Because it's got less mileage. We could not explain this much. $615 we could not explain. So this is what we call residual or error. Our model explains the green line, does not explain the red line. The red line is an error residual that we do not know exactly what's going on there. So now the question is, how much of the car price variation we explained? The difference was $2,028, right from there to there, out of which we could explain the green line, which is $1,413. So we actually could explain this one divided by that one, percent of the price. That's the idea behind R squared, roughly speaking. So this is what we're going to do now. Predicted minus average is what we could explain. And the total is actual minus average as total. So we took the difference between these for each of these numbers, squared it, added them up. Then took the difference from this to this for each of these cars and added them up. And when we divide, we get R squared. Here, for instance, our predicted prices. Again, we computed using this formula here, intercept and slope for each car. And the Excel file you can do on your own. You can compute each one, every one, and then go from there. So what R squared really is how much we explain versus what the total is. So back to R squared, this is what we have. And here's our graph. And we give these notations. This is yi, y1, y2, y3, the actuals, these ones. Y hat is the predicted ones, and y bar is the average, which is this one, the average. What is this now? R squared. Well, if you say predicted is your yi hat, average is y bar, actual is yi, and average is y bar, and we get R squared formula right there. And this is what it is. So explained through regression is sum of squared of through regression. That's SSR, explained portion. Total is called SST, sum of square of totals. So the totals from there to there, sum of squared totals, and that's what this one is. So R squared is SSR over SST. Now let's look at SSE, sum of squared errors. Now, what is SSE? SSE actually is the error portion, the red line here. This minus that is the error, which is yi minus yi hat squared is the error portion. Now if you recall your variance formula, what was the variance formula? It is basically x minus mu squared divided by n, or n minus 1, depending on what it is, sample or population. So from each point we subtract the mean, that's the difference, the error, the deviation, square it, add them up, then take the average of it. That's what we have done really. These are our errors, these ones. What if suppose you divide by n, or more like degrees of freedom? And the degrees of freedom in case of regression is n minus k minus 1. there. N minus k minus 1. Not n minus 1, n minus k minus 1. What is k? Number of independent columns. In our case, it is 1. That's the independent column, miles driven. We only have what independent column, miles driven. Suppose we have 2 columns, miles driven, age of the car. Then we got k becomes 2. Suppose you have 3, miles driven, age of the car, and suppose condition of the car, in some 1, 2, 3, 4, 5, whatever. Then k becomes 3. So sum of squared error and mean squared error. This is like variance, what we have done so far. If I take a square root of this one, what do I get? Standard deviation, which is we call standard error. So standard error in regression is this. Now, if you do not remember the formula, can you derive it? Well, look at the picture again. What's error squared? This minus this squared. Add them up. Sum of error squared, that's SSE. Divide by the degrees of freedom, which is n minus k minus 1 square root, and that you get the standard error formula. And now we got the 2 formulas taken care of. R squared and standard error. Now what you should do really is draw the picture, see if you can recall the formula, not by memory, but analyzing it. Can you bring the formula back just by thinking about it, not memorizing it? If you can do it, you learned it well. Okay, so let's move on now. So here is how Excel file looks like. Actual driven. You can find the slope intercept and then predicted price, which simply is intercept plus slope times miles driven. Then residual, that simply is actual minus predicted. Residual squared. Average price, actual minus average. Follow these ones, follow the logic we have, and you can get R squared and standard error by simply, without any formula, simply by following the logic. That's the Excel output. So SSR, this explained portion, is this one. Residual, this SSE is this one. And the total SST is total of these ones there. What is R squared? R squared is explained over total. Explained over total, which is what you see here. Explained over total is R squared 0.7493. What's the meaning of this? Meaning of this is that in our model, about 75% of the car price variation is explained by the number of miles driven. 25% is why we go to see the car. SSE is yi minus y hat squared. And that happens to be right there, 14.991, that's SSE. And the total is SST. Standard error is SSE, which is this one, divided by degrees of freedom. Degrees of freedom is 24. Why? Because 26 of cars minus one independent variable 1 minus 1. So 26 minus 1, which is 24. You do that, 0.7903, which is what we have right there, standard error. And this is your R squared. Now, is this a small number or large number? Standard error is like standard deviation. Same concept. Is it small, large, medium? What is it? While you compare this to the mean, like in coefficient of variation, when compared to the mean, which is 14.67, we get 5.42%. So you can say, in roughly speaking, not exactly accurate, roughly speaking, that our model is correct within about 5.42%. So on an average price of car, which is $14,672, we'll be off by about 5%, 5-6%. That's about, let's say, $700-800. That's about $790. So they'll be off by that much, 5-6% approximately. That's what standard error is. This is pretty much our coverage. Now going back, looking at this picture, can you derive the formula for R squared and standard error? This is yi hat, and y bar. Try this, you'll succeed. And we end our discussion right here.